Oh, there, get some people in. Okay, so last lecture is today. I'm gonna have one last assignment that shouldn't take you more than 5 minutes. That'll be up today and due the end of next week. So you can just do it sometime this week or next week or over the weekend. So it shouldn't take you more than 5 minutes, and that's gonna be the last one. Hopefully you've taken something away from the seminar. I don't really, necessarily care what it is, but as long as it's something that it's been, some use of time that's, fine, then, all good with me. So today we're going to talk about software engineering, what exactly it entails and the process for software engineering, and then a bit about reverse engineering. And I'm going to try to do sort of an interactive example with software engineering here. So we've thrown around, the term of software engineering a lot, but I want to clarify what exactly software engineer is and what the process of general software engineering looks like. You're going to learn, a lot more comprehensively about this in 320 if you take that, but 326 as well with web development does go over a fair bit of it. But generally, what you have when you start with a software engineering problem is you have a problem or a problem statement, right? And most engineering tasks work out this way, right? Where you have some general problem and you have to come up with some solution, right? But the process of how you get from that problem to that solution is the hard part. So I'm going to write out a couple of steps and then I'll sort of go through and clarify what would happen within each one. Right. Clarifications. Market. Research. And then we go into design. Implementation. Testing, iteration, followed by maintenance. Okay. So starting from the top, what you would generally come across is some sort of problem or a problem statement. And this is usually either handed to you by someone above you, or it's something that you would find. You would find some problem that you want to address, right? Good example would be when COVID first started, right, there was no panel to be able to track everything all at once that the government had initially. So a lot of independent developers came out with their own COVID trackers, right, at the beginning. And then eventually larger corps had their own, and then the CDC had their own, right, that actually tracked things nationwide, or in some cases, across multiple countries, right? And so, that was initially just a problem. And so then what you would have to do is you would have to go into the research phase. And this is where first you might ask clarifying questions, right? Which this would be for whoever the problem statement is from. And so examples, right? Say that your problem statement, again, is for building a COVID web panel, right? That's your problem, you need to build one. And clarifications you might ask would be, okay, well, who is the intended audience for this panel, right? Is this meant to be for the average person, right? In which case it should be very simplistic and, maybe just a graph of sorts, right? It should be like the main factor. Or is this going to be for more advanced like statisticians or researchers or whatever else, in which case you're going to want a lot more data available in a lot more variety of formats, right? Not just like a simple interface, right? You might also want to ask, well, what sorts of data should this include, right? What sorts of countries should this be about? Is this, just for the US? Is this for specific states? How fine-grained do you want this data? Do you want it by, county level or city or whatever else, right? So you would want to get out all those clarifying questions that you need to know in order to start your task, right? Throughout this process, it's important to maintain balance. And that's really what makes, in my opinion, at least, software engineering hard. Isn't necessarily that, writing code or whatever is difficult, but that writing code in a timely manner and figuring out what code to write in a timely manner, that's the hard part, right? So with that being said, right, that means that you don't want to take too long on any one of these steps, right? And especially when you're looking at, say, Facebook or Google or Apple or whatever companies, when their mottos are literally like move fast and break things and stuff, right? Like Facebook was famous for that motto. That means that while you should still do, the necessary research in order to start, your design and implementation of your engineering solution, you don't want to be taking a super long time, right? Which is oftentimes the reason why like research, and academic research stalls out or takes a long time to be done. It's because it's a very thorough and drawn out process, right? With engineering, as it is today in the software world, right? You want to be thorough, especially when it comes to things like security and stuff, but you also want to not cover a lot of things that you don't really need to cover in order to get your initial product out the door. Right? Other examples of things you might do in this research phase would be like market research, right? So this would be something, for example, that if you're going in to design a user interface, then you would want to look at who the users are and look at how to properly build that interface, right? Great examples of this, right, that have failed market research. There's this website, Killed by Google, right, that has basically a list of a bunch of Google products that were discontinued, right? And a lot of them are due to improper market research and that they never caught on and never got popular enough to be maintained, right? Good examples, Google Plus, right? It was supposed to be like a social network, but wasn't really a social network. It was kind of like a profile page hybrid. It was weird, right? And nobody really liked it, right? And that's a failure on the market research part to know what people actually wanted on the receiving end, right? YouTube gaming, right? When you have to compete with a large number of other streaming services, are you actually developing features that people want, right? And in the case of YouTube gaming, when you compare it to like Twitch and things, they didn't really do that, right? And so it didn't really last that long, right? Dragonfly, right? Being a search engine that's supposed to be compatible with Chinese censorship practices, right? Well, one is that you're trying to, have your engineers, who most of which are going to be engineers that wouldn't be comfortable doing this, right? Some of which would probably walk out over this. There was, I think it was actually at Google, a walkout a couple years back where there was some engineers that were supposed to work on like a government defense drone, and they said no and they walked, right? They just quit. When you're working on things like that, where you have ethics issues, right? You have to keep that in mind, right? As well as now you're competing with a bunch of products in China that have been around for a long time, right? That already is backed by the government, like Baidu and whatnot, right? That's what you're competing with. And so that's also in market research, is it feasible to really, do something like this? Other examples, right? YouTube messages, right? A very short amount of time that it lasted, right? Which is direct messaging on YouTube, right? Is that really something that people would use or want, right? And clearly it wasn't, right? And so there's a lot of these products, right? Google is notorious for having a lot of products that it develops and then just kills off because it wasn't properly vetted before people just started working on it as to whether or not this would actually work. Right? And then of course there's other independent research you can conduct on it, which is like what kinds of languages or frameworks or whatever else you might need to know for it, any sort of background information you need, that kind of stuff, right? But those are the main components that go into like research really before you start designing. So after that's done, right, you can move on to the design phase, right? And this is where you would design phase. Ooh. Right. And this is where in the design phase, you would start designing your solution that you're going to implement in the next step, right? Typically, this would entail thinking about all of sort of the process involved with implementing the solution and distributing it, right? So you're going from like the very start to the very end. So this is thinking about what kinds of systems do you need to make, for example, if you're doing this at a company, right? What kinds of systems do you need to have at the back end on the company, right? How is that going to work, right? Who's going to write the code for those systems? Who's going to maintain those systems, right? You want to design the end user experience as well, right? So say that this, this is a COVID tracker, for example. Do you want to make this available as a web application, as a smartphone app, both, right? How do you want to do this, right? And then you also want to think about the actual design of that application or web app, right? And so those would all go into the design phase, right? And that's not just front-end design, but thinking about, of course, all of the backend and code involved, right? How are you actually going to write this? How are you going to pull data from which sources, right? Are you pulling this from each state's website, if you're doing this for like the US, for example, and then sort of just like agglomerating it, right? Are you going to pull this like every minute, every hour? How often are you going to update this stuff, right? What kind of server load does that cause to update it that often? It's questions like that that you would address in this design phase, right? Once that's done, right, you would move on to implementation. And this is where you basically, implementation is usually fairly straightforward. It's actually usually the lesser time consuming step if you've designed things properly, because you should at this point just be able to like very simply take the design that you've made and then make each part, right, implement each part. And so oftentimes, depending on how complex your design is, your implementation process would be longer or shorter, right? And then at this point, right, you've sort of entered into, with these more or less these three steps, design, implementation, and then testing, you've entered into sort of this iterative phase, right? Which is why I say testing/iteration. So the idea is that you would design some component, you would implement that component, and then you would test it, right? And then if you weren't done with your problem yet, you would go back to design or back to implementation, right? If you need to completely change how you design something, or you need to change your like foundational ideas or beliefs on solving the problem, then you might go back to the research step, right? Which is why it's a good idea to have, try to be as thorough as possible in the first place. And then you would proceed through the steps again in linear order until you again have testing, right? If after your testing you're done, great, you can move on to the maintenance step, right? Which I'll cover in a second. If testing is, unsuccessful, then you would find out where the error is and go back. If it's an implementation error, then you would just go back to implementation and fix it. If it's a design error, right, then you have to go redesign it, implement again, and then test again, right? And so it's generally called for that reason, like an iterative process. And also for that reason, you might see it called like something analogous to the software lifecycle. Right? And so this is sort of like roughly analogous to this, right? Planning and analysis are more or less the similar steps to what I said is going on to research, right? And then you would design it, then you would implement it, then you would test it, and then you would go on to maintenance and sort of repeat this process, right? Now, the maintenance step, once you've reached that point, that is basically the step in which you consider a bunch of questions about how the software, whatever you've engineered, is going to be maintained into the future, right? And so this includes not just like whether or not you're going to be updating it and how you would do that, but this is things like, if I want to change, right, anything about it, is it easy to change, right? For example, if this is a COVID tracker, if I just want to like easily remove a state or, highlight a state, can I do that very easily? Or is it something that I have to like redesign the whole program in order to do that, right? Thinking about, is it properly documented, right? If you don't have proper documentation, then you could end up in a scenario where you no longer are the main engineer on this product or this project, right? But it still needs to be maintained. And so how then does someone know, what to do with it if you haven't documented things properly? Right? Great examples of this are at, uber huge tech companies, right? Where they have engineers that are maybe 8 to 10 years ago, right, would develop some foundational system that then they would build up on top of, and things would change, right? And eventually they would get to the point where that system was obsolete or needed to be changed in some way. And it's not documented because it was built when it was just like a startup, and it's not properly, they are much more concerned with developing software very quickly at that state and not documenting it thoroughly, right? And so then you end up with like modern engineers having to go back and look at like, what were these people doing 10 years ago? How was this written? All that kind of stuff, right? Which is a big waste of time. And oftentimes just ends up with you throwing out the code base and starting over. So that's why maintenance is actually a really important step to think about, right? You want to make sure that your code is cleanly written enough and you've thought about these problems in advance so that you can actually make sure that into the future, this software will continue to work, or it can be updated, or it can be made obsolete, but in an easy way, right? With a smooth transition. So applying this then to an example, right, is what I want to do next. So what we're going to do here is I'm going to give basically a prompt, right? And we're going to walk through and get some ideas from people on some different parts of these steps. So let's actually let's find a realistic prompt. Software engineering prompts. There's not like interview questions. Let's say problems. Biggest problems of software engineering. Let's see. Let's see what maybe good to look at. Business analytics. Okay, so we'll just do something with business analytics, right? Let's say that, for example, let's say that you are a newly hired engineer at a company called X with a capital X because they're like cool and modern. Quibex, right? That's your new company. You're hired at it. They just started, so clearly they're worth $10 billion already, because that's how tech companies work now. And you're hired as an engineer there, and they offer business analytics solutions to people, right? And so your broad problem as an engineer is to do something involved with offering business analytics, right, to a specific customer, right? This specific customer, right? Let's say that this specific customer is a chain of bakeries, right? A chain of bakeries, right? Let's say they have like several hundred locations throughout the US, right? And they want to they want to figure out how to get into the online space of selling their goods on the internet, right? They want to see if that's feasible or not, and they want to see how a good system would be to implement that, right? So chain of bakeries wants to sell online, right? And so maybe, right, a next step would be like, this is a very vague problem, right? And so next step might be, well, clarification questions. Are you looking to like sell things online for people picking up at stores, like only for like an online order system? Or you can order on your phone and then pick up something at a store? Or are you looking like to do shipping stuff? And then they say, oh, no, we didn't mean shipping stuff. We meant actually just some sort of ordering system so you can order on your phone and then come pick up at a store locally. And you think to yourself, well, that's much easier, right? You should have said that in the first place. But that's how problem statements often work, and that's why clarifications are important, right? So you want to sell online, right, and then pick up in store, right? Okay. So the thing is that now what you could do is you could go into the research. Right, you can go into the research section, right? And probably the first thing I would go into here is I would go into market research. I would look at and see if I'm developing, this way for them to sell things online and pick up in store. Is this something that I need to, develop from the ground up, or are there some off-the-shelf solutions that I can just go pick up and, configure for them and stuff, right? Is that something that I can do? And in that market research way, let's say that you do find, there are a lot of off-the-shelf solutions available, like DoorDash and stuff, where you can, use those to order and pick up in the store. But the bakery is very stingy and they don't want to use these services because they have a higher commission, right? And your boss says, we can give you this, but we'll charge a lower service fee, right? Other places, maybe they charge like 10% service fee, we'll charge like 2%, right? If you use our in-house solution. So now it's your job to develop an in-house solution for people to be able to order things online and then pick them up, in the restaurant, right? Or in the bakery, right? In store. So now, right, now you might want to do some further research, right? Maybe you want to like look at different frameworks you can use to develop this, and maybe you want to look at what sorts of security measures you need. Maybe you want to look more realistically at what stores this should be rolled out to, in a specific order or something like that, right? But we're going to assume that you've done your research, you've looked at things like that, and we'll go into design, right? So what might be some important aspects of design to consider when thinking about this problem, right? You can think about it as, user experience type thing. You can think about it as how the user is actually going to do this, right? What sorts of platforms are they going to use? What should the interface look like? You also might want to think about, backend, problems. Are you going to be, developing and running all this stuff in-house? Are you going to try to outsource some of it? So what might be some design considerations to take into account with this, general task here? I'm going to go first, and I'm going to say, I think that it would be important. To look at other competitors, right? Competitors to how they implement stuff like DoorDash, right? Look at other competitors and see how their interfaces work, right? So I mean, like, do they have like a store page that you go to and then you can click on items to add them to a cart and then like check out, right? Is that generally the process, and what kind of interface does that look like? So that's going to be my contribution. So what would be an example of something else that we could look at? We'll give people maybe like a minute or two to come up with something. You can unmute or you can use chat. How users choose which bakery to pick up from. Yeah, that's great. That's an important design decision to make, right? And I think this is also seen a lot differently depending on where you do online shopping experiences, and that's definitely very frustrating when it's like done the wrong way, right? A good example of when it's done the wrong way, in my opinion, this is my opinion as a consumer, right, is Walmart, right? You can go to Walmart and you can search for something, right? Here's like, for example, this monitor that I wanted to purchase, right? Or like maybe I'll do something more generic, like a router. Right? So I look up router, right? And if I'm going to Walmart, right, I want to go get something in store. I want to go pick up something in a store, right? And so what I'm going to do is I search my thing and I'm going to say free pickup today, right? Which I have to like scroll down and find on the side, right? And let's see. Which one was that it? Oh, you know what? I think they actually fixed it. Okay. Well, like a couple months ago when I was using this, the option on the side was free pickup. It wasn't free pickup today, right? And so you would click on free pickup, and then similar to this stuff here, you'd have a bunch of options, a bunch of which you could actually pick up today, but a bunch of which you would be able to pick up because they would ship to the store and you could pick them in like a week, right? And like, if I'm going to be buying something from Walmart, I want to go get it like today. I want to like pick it up on the same day I order it, right? And I want to go pick it up. And so that's something to consider, is that general process. Do you want to like have those sets of filters, right? A comparison, we'll see how like Target does it, which is like a direct competitor. Right? If I search like a router, right? If I search a router, let's see. So they have in-store pickup, right? And then they have buy it at the store, right? So we'll assume we're gonna like, we want to pay online and pick it up at the store. So we go to in-store pickup, right? And so let's see, so you have a bunch of different options, ready within X hours, right? So maybe is that something we want to consider? We want to like, how long, do we want to like have a turnaround time? Do we want to give people like an estimate, right? Let's see, let's buy it at the store. If we're doing like buy it at the store, I don't know if that's like a difference between paying online or paying in person, right? I don't know. So maybe like clarify those things, right? Make sure things are like worded properly. But yeah, that's important to look at something like that, right? Is it something where you'd like select the store before you do your process, before you look at what goods are available? Or is it something where you're going to look at what goods are available and then select your store, right? Because if you do it that reverse way, then maybe you run into the problem where you selected a baked good and it's not available at the store that you selected afterwards during the checkout process, right? So it's important design decisions to think about like that. Yeah. So how choose bakery. Right. And maybe we also want to like do this location based. Maybe we want to like try to determine their location, right? And then like choose the nearest branch, right? Or maybe we just want to let them select, right? We don't guess their location, right? And let's say we go over all these questions, we answer all these questions, we design our interface, we design our backend, right? All that's designed, and now we go into implementation, right? And, we'll say that implementation goes fairly smoothly, right? We've designed things very thoroughly, right? But during the testing phase, although we tested things just fine, we come across a problem, right? In that there's something that we didn't consider, right? So let's say that our problem is that while rolling this out, right, we found that a lot of users in the Midwest, right, don't actually order online and then pick it up in store compared to a lot of urban areas, right? Which, would make sense. But let's say that we do some research and we find out that the reason for that is that we decided to only go with a mobile app, right? And a lot of places, a lot of people in the Midwest maybe don't have cell service in their house, right? And so they don't really, let's say they don't order from their phone because of that, right? Maybe they only order from their computer, right? And if we only have a mobile app, then, that might be a problem. We're missing out on that segment of customers, right? Or maybe people don't know how to use a phone or a mobile app, right? And so they would have to use the desktop. So in that case there, that's something that we thought about, and we thought that most people would use, the mobile app, right? And so that's why we designed it that way, right? And so that kind of makes sense, and that would be a trade-off, right? Do you want to spend engineering time developing and maintaining a web interface for this as well? Or do you only want to do a mobile app, right? And a good example of that is Uber and Lyft, right? I don't know if they have web interfaces now, but at least initially, if they don't now, they didn't several years ago when they first started coming out. They purely were an app, right? And that made sense, right? Because most of the time people would be out and they would Uber from out to get somewhere else out or to get home, or they'd Uber from home to elsewhere out, but they would do so in an urban area on their phone where they were pretty much guaranteed to always have access to internet. Right? Same thing for say you want to, make reservations. Right? And this might be something that's relevant in our system. Do you want to be able to, through this online system, reserve a baked good for a day or two in advance, right? Or do you only want to be able to pick it up at one time of day? That wasn't initially in the problem or the design, but maybe it came up because someone suggested it. Someone, like a customer said, hey, I used your system to order this and I wanted to place an order for next week, not today, right? I just wanted to get it, in their system. Well, we don't support that. You have to order on the same day, but I can't. I'm going to be on a plane, right? I don't know. I'm going to be on a plane. So stuff like that, would be important to consider in the maintenance phase, right? Where you have all of these suggestions for improvements, or you have problems, right, that come up. And so you have to think about how are you going to develop a system that is able to, be updated or be maintained by people other than you, right? And unfortunately, it's the step that's often neglected, right? So I think a good takeaway from this is all of these things are important, right? And they all deserve some time to them, but the hardest part, again, in my opinion, is determining how much time to allot to any one step, because you can go down rabbit holes on each step, right? For example, in research, you could think about doing some big, market research study where, in the case of this baked good problems, you have all the stores send out surveys to consumers where you're like, how much would you like to, have this be able to be picked up in store, right, and ordered online? Would you like that to be a phone app? Would you like that to be a web app, right? Do you want it to have order in advance features, right? And so you could do that, right? You definitely could. In fact, they should probably do that before coming to you, right, as an engineer. But oftentimes, engineers are just handed a big problem and said, just do it and we'll pay you. But you could also spend a lot of time in design, right? You could think a lot about the interface. You could go super, super deep on research into competitors and how they do their interfaces, right? Or you could spend a long time implementing, right? You could spend a long time making a very clean system and, you know, making things optimized, right? Making it run like 1% better in some fringe situation, right? But that might take you like a month to do. And so there are people who do that, right? And that's important in some cases, right? A great example, right? Intel and AMD, two of the biggest processor manufacturers, right? Their most recent lineups of processors, AMD's was released a couple weeks ago and Intel's is coming up next year. They don't have new designs to them. The change is in their efficiency, right? They're more efficient. They're able to run programs essentially at a faster rate because they can do it more efficiently and they have the same power. And so that's something that it makes sense to do a long time on implementation to make this implementation much cleaner because that achieves, you know, better end performance, right? But you know, they decided to do that there instead of going back to the design phase and then redesigning things. And you have to think about the trade-offs, right? You have an old design, right? So I think that each step, you know, you can go into your own rabbit hole. So just be careful that you're spending the appropriate amount of time in each step. From what I've heard as well, when you're doing like internships or jobs, that's also one of the largest parts that people get caught up on during their internship or job that causes them to not get a return offer or causes them to, you know, be stuck in a certain position, is that they are able to do the work really well, which you can do in the interview, but once they actually start their work there, they quickly find themselves stuck because they've taken too long to do certain steps, right? Either they've taken too long designing their program and then they're out of time. And they have to tell their manager by the deadline that like, hey, I don't have this done because I spent too long considering this edge case that'll never happen, right? So I think that's important. Okay, so the reverse process now for this, changing gears, the reverse process is called reverse engineering, right? And more or less, it's kind of the same process, but it's done in reverse, right? As an example, right? Say that you want to figure out how a program works, right? We'll pick a piece of software. Let's say we're just going to use Target's ordering system again, right? So going through the testing step, right? So we'll go backwards, right? We'll go to testing, right? So in order to find out how this works, we want to document as much about it as we can, right? So we're going to test all kinds of behavior about it. We're going to test what happens when you click certain buttons, right? Well, clicking this gets up to the home page, right? We're going to test like these different category systems, right? We're going to like see all these categories. We're going to click things. We're going to see what happens when you add them to our cart. We're going to check out all these filters, right? How they work. And we're going to make some large documentation about how this really works, right? And then what we're going to do is we're going to think backwards even further, right? We're going to think about the implementation, right? And think about the design. So thinking about the implementation, right? We might be able to determine, right? This is clearly a web app, right? And we might even be able to determine, you know, what kinds of things this web app uses, what kinds of software it uses, right? So maybe let's see, maybe we can go to like, let's see, let's go to, we'll go to the source code of the web page, right? And we'll see if they use anything in specific, right? Any sort of like framework or something, right? And most people aren't going to be able to really like look through this, but I'm just going to do this like as an example. Okay. So looking into like implementation details, right? These basically are a bunch of URLs, right? And we can see that each of these like have category stuff with this like C/ and then some name of a category. So then we think, well, if we're designing a system, right, like a database that contains all this data, then we're going to separate them into these like types of categories, right? We can go further down and see, of course, like the language that's being used is JavaScript, right? And we can really dive in nitty gritty into this code and see how it works. Of course, I'm not going to do that, but that's essentially what you're doing. This implementation step is finding relevant pieces of software and then reading the source code, or seeing how you can read the source code and then sort of building then this implementation, right? And then from there, you can work backwards further and you can see why did they make these particular design decisions. So the example, right, is, well, we saw by clicking around in the testing that they have a bunch of these categories in their filter system, right? So clearly that's some sort of database that has these categories. And we can think about why. Why is that in a database, right? How might we want to design that database, right? And so that process of thinking backwards is generally reverse engineering. It's used a lot more in security when you're thinking about like reverse engineering viruses, trying to find out how viruses work. But it's also used a lot by competitors during this market research phase, right? If you want to see how Target's web store works, maybe you can make yours a little bit easier, right? You don't have to actually go from the ground up. And what we were doing, right, when we were doing market research and poking around the Target website and Walmart website to see how they worked, right, and coming up with our own market questions, that's basically, that's reverse engineering, right? We're thinking backwards. We're starting with an end product and thinking backwards. And that's what reverse engineering is. Right? Okay, so if you're interested, software engineering, you're going to start with software engineering in you're going to start with engineering in CS 220, really. This is titled programming methodology, but you're basically starting on writing larger pieces of software in this course. From there, 320 and 326 are the next engineering sort of steps. 320 is directly software engineering, and that includes a lot more of the process that I detailed here. Like it's very specific, right? You have to like write proposals and stuff. And 326 is that, but sort of tailored towards website development. It's a lot less structured. So if you kind of just want to like, write website stuff or, design websites, then maybe 326 is better. But otherwise, I would say 320 is probably more useful. After that, there is a 520 for those who are interested, as well as 529. And these two are much more software engineering focused, right? They're like master's level software engineering courses. I don't necessarily think that they're, needed, but if you are interested in something like that, then, it's fine. I think that most important, honestly, is that you take the fundamental, 320/326 and 220. And with the information from there, use those to develop your own projects and use those to, get internships, right? And actually work on these skills at an internship. Because you can talk all about this, we can talk about this for a long time and, go in depth about these processes, but you're not going to be able to do it well until you actually do it yourself, right? So the most important thing is just to do it, right? Do it in some way. As far as reverse engineering goes, you'd be starting looking at that with again 220 as well as 230. 230 is going to be lower level system stuff. After that, you'd probably be going into looking more how computers work. So in order to do, again, reverse engineering, which is more done in a security sense, you generally want to start at, the lower level and build yourself up so that you can understand how to go backwards. Right? Digital Forensics 365 is also a great course. I think it's important. So that teaches you more about how computers represent data and stuff. And then after that, you can really kind of branch off into whatever you're interested in sort of reverse engineering, whatever, right? Whether that be, you know, let's say like, whether that be like computer architecture, or I think advanced, which one is it? Just modern computer architecture, advanced digital forensic systems. I think this one goes more into like viruses and stuff, as well as does, which one? System defense and test. Those are all kind of reverse engineering. Most things that you find in the securities, you know, kind of school will have some elements of reverse engineering into it. Okay, so that's pretty much all I wanted to talk about. That's the last lecture, so I don't have any more lectures, but again, I'll put the assignment up on Moodle to do sometime this week or next week. It'll be just due the end of next week. Technically you have, I think it's November 30th is when finals start or something. We don't have a final in this class clearly, so you know, best of luck in studying for other finals. And so sorry that, you know, this is all online and kind of a crappy experience for most people. It's not any better for instructors, kind of everyone's in the rut here. So, you know, I genuinely apologize that that's the experience that everyone here is getting. You know, this wasn't what I started with. And certainly if I had started university with this sort of experience, with everything being online and, you know, seeming half-assed, like I certainly would be I would be upset, right? I would be upset that I spent money on this, right? Just know that definitely people in the CS department are trying to make this better. And, you know, hopefully we'll be in a place sometime next year where we can, you know, resume more in-person instruction as vaccines and stuff come about. But for now, I just say, just hang on and kind of take the time to, I'd say like use this time as best as you can to work on yourself and work on projects and sort of use your time to do things that you wouldn't normally do when you had a lot of in-person instruction. So use this time to kind of develop your own critical thinking skills, develop time management skills, right? Project management skills, stuff like that. You know, I think that's kind of really the best that you're able to do. Other than that, and again, you know, best of luck as you guys go throughout your degrees here. And if you ever need anything, have any questions, you know, my emails are open. I might be slow to respond sometimes, but I will get to it. Yeah. So have fun with the remainder of your classes and with finals week. So hopefully you've taken something away from some amount of lectures.
Thank you.